Now we're going to play with the top 250 movies on IMDb. Again, so recall that we can just look at the source code and scrape through, as I've reproduced here. I'm opening up, here's our chart top, ta-da, it's got our table here, just looking at that tag assigned to table, gives us, here's what we're working with. Okay, so first, we want to check to make sure we're actually allowed to scrape this data. And so we're going to use the robots text library. And it'll tell us if we can poke around, if we can scrape the data out, just to see if paths are allowed. And so if we use the paths allowed on the website we're interested in, we'll find out. And so for IMDb, which is why I like using it as an example, we are allowed to poke around. Now, if I were to poke around on, say, Facebook, no, that website is locked down tremendously because, well, their business model is data. So, yeah. So we can't easily access Facebook data directly from the web. You have to request it yourself and download it. And then it's pretty easy and relatively easy to play with. All right, so your turn. I want you to open up the application exercise 8 entitled very creatively IMDB and web scraping, and open up the .r file in that repo and follow along and fill in the blanks as we go based on the upcoming slides. It's a code along. So here's the plan. We are going to try and go from this data set or this website and get a data frame that has the title, the year, and the rating, which I've highlighted here to show you where those pieces of data are. Because in general, with web scraping, you don't go in blind. Look at what the website is, go in with a goal, and try and then get that data out. This is a rescue mission, so to speak. It's not an exploration. Precision extraction. Okay, so that's where we're going. So, okay, here's our roadmap. So we're going to read through the whole page just to get a sense of what the data are. Just, again, to get familiar. Next, we're going to scrape movie titles. We're going to save those as titles. We're just going to go down, column by column. Then we're going to scrape years of the movie was made and save it as years. Shocking, I know. Then we're going to scrape the IMDb ratings. These are, well, the fun, most exciting stuff, because the rest of it you can get wherever. And extract that as ratings. And once we have all three of those pieces, we're then going to create a data frame and call it IMDb Top 250 with the variables title, year, and rating. That is the plan. Okay? Ready? Cool. Step 1. We're going to read in the whole page. In addition to reading in as a human, I actually have to read it into R. And we're using RVest. We're reading HTML for the web page here. IMDb, blah, 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 blah. Okay, this guy. And I just had it spit it out. So here are some of the R code, or some of the string data that we've extracted from that HTML doc. I mean, we've extracted all of it. It's all here. Here's a little teeny little snippet because I didn't want it to overwhelm the page or accidentally have the markdown file try and process it. But that's the data we are going to clean up. Okay, so let's take a peek deeper into this web page, and what it gives us is a list with two elements, the head and the body. So we will be crawling deeply into the body mostly, because that's where all the data are. And we'll be working with lists, which are, to be honest, one of my least favorite types of data structures, but they're a good one because they're the most encompassing. Okay, so we are going to have to convert that page into something a little more nice, like a data frame. So let's look at the class of our data. So just like in the videos that I made ages ago on data types and classes and all that, that's going to come and be helpful. So you might want to rewatch those if you skipped them or you've forgotten. So here we've got class, and it is telling us that we have an XML document and XML node. So that's the kind of data we're working with. So step 2. So we have our big data. We have some idea of where we're going. So let's go and grab our first piece of information. Titles. Okay. Remember way back in the day, like 10 minutes ago, we used the selector gadget to figure out which little node we want to poke in. And it ends up being dot title column and A. So it's got down here. So what we're going to do is pipe pages into HTML nodes. And we're going to ask it and just copy and paste that. Sometimes my mouse shows up. This little piece of information here straight in to our HTML nodes. And it should give us 250 rows of data that are just that little piece of information in theory. So now let's like carve in and like just get the text out, because the rest of that is HTML links, and while that's useful, it doesn't serve our purpose here. So we're going to pipe that process node with HTML text, and what that does is it scrapes out pretty much all the code that is not a string. And luckily for us, it comes out really nice and clean with our titles. Ta-da! Just by piping pages into HTML nodes and piping that into HTML text. It's beautiful. Okay, so now we got to save it, because it's great that we did all that piping, but we didn't assign it to anything. So while it exists on our screen as a printout, that's it. That is all it exists. If we just were to end now, no data. So we have to assign it. So we assign it with the arrow to make a new object, which is just a column. Then when we summon it, we get our column of data without any of the hot mess. It's quite nice. Okay, so that is titles. We will come back to smush these all together later, but that's the process. Okay, so step 3. So we got the titles. Now let's get the year that the movie was made and save that. Okay, so we go back to selector gadget, and it tells us here that it's captured under secondary info. Cool. So let's grab that. Same thing again with HTML nodes and secondary info. So we can see just from peeking here that it's going to give us what we want. But it also seems to be giving us a little extra. So as we can see here, ta-da, if we were to just apply the exact same process we used for getting the title, we don't actually get out what we want. As you can see here, we have the open and closed parentheses around our data, which in turn is causing R to treat this number as a string. Or, well, technically it's a date, but for our purposes, it can be just treated like any number. Okay, so we need to clean this up. So we need to do 2 steps. 1, we need to remove those parentheses, and that's a string manipulation. And next, we then need to convert our data from a string into a number. And we can just do that with as numeric. But that is our next steps, because it's not perfectly clean and ready to go. So then, to get all that, we're going to use stringer. So stringer provides a cohesive set of functions designed to make working with strings as easy as possible. functions from stringers start with str underscore and then whatever property you have. So you kind of at least know where you're looking. For example, this includes like string remove, which will remove a pattern from a string. So here I've got a string of Jello. I have a string that contains the word Jello. And what I want to do is remove EL from that. So I pop that into our pattern. Is it the second option there of L. So now when I remove L from Jello, I get JLo. Yes. Yes, I did do that. So in addition to this, we can use string replace. So say we don't want to just summon JLo from Jello. Say we want to actually turn Jello into like a meaningful phrase, or say you are perpetually misspelling things. We can identify a pattern that's as simple as J. And so that's our pattern. That's the string we want to find. These can get very complicated very fast if you dive into regular expression. But just basic strings is a good place to start. And we want to replace every instance of J with H. So if we apply string replace using the string Jello and identify all cases of J with a replacement H, we will get as lovely output, hello. Yeah, it's super helpful, I promise. So now we need to clean up our text. So what I've done is I've piped in string remove. So you'll notice that this doesn't seem to exactly say just that parenthesis. And that is because we are technically using regular expression and we have to use an exit character so that R knows that this isn't the beginning of a function with its open paren. And so we have to use forward slash? No, backslash. The slashes I've highlighted here. And then we get to put in our actual symbol. And this will remove the open parenthesis. And that is it. So we're getting closer. So we can do that again and just pipe that whole thing through again and have string remove the close parenthesis. Okay, we are close. But you'll notice that we're still working with a string. It's still in quotes. Now we're going to pipe all of that through and ask it to be treated as numeric. And remember, for pipes, sorry, I thought I had a typo. We go from the top and just pop it in, and then everything in here gets popped in here, everything in here gets popped in. Oh, you cannot see my mouse. Great. Okay, so we go from pages, and where we put pages into the first opening, so in the first object, oh, I'm blanking on the first position, comma, and then the next thing. And then what we do is we pipe that whole thing into the next level, pipe that in, and lastly, we pipe it all through as numeric. And now we have numbers. How do I know they're numbers? Because they're not little quotes. Cool. So we want to save it. Before we go any further, we want to make sure we assign what we've done to an object. And so what we're going to do is assign it to years. Very creatively named, I know. But it seems silly to give it some fancy name, like Svetlana or something. Okay, so now we gotta put, oh, I lied. We gotta get those ratings, so that almost proprietary data. Cool, so we want that last little piece, as we can see in the highlight here. It seems to be identified using strong, so that the strong node. So now we're gonna pipe through and see if that actually gives us what we want. Cool. It gives us a little more info in the strong title, versus this little piece here. So just nice. So it gives us more information than we would have otherwise gotten. So let's parse it out. And thankfully, we don't have to grab the first 4 characters. I lied. First 3 characters, because it only rounds to 1 decimal place. But, and have to like parse this piece. So we can just get straight data, which is nice. Okay, recall from 30 seconds ago that we have strings here to start out with. It doesn't know it's a number. We have to teach it it's a number by piping it through. Thankfully, we don't have to do anything fancy, and it shows up all nice. Ta-da! We're going to assign that to ratings, and we've got our ratings. Now our last step, the very, very exciting one, is we get to create a data frame using data that we scraped ourselves. We scavenged it. I mean, yeah, there's a lot of fun metaphors for like hyenas. So yeah, we're scraping that data, and yeah, so let's just make a tibble. So we use tibble, and we assign title to titles, year to years, rating to ratings, and put that all in an IMDB top 250 object. And let's have it spit it back out. We now have a tibble with 3 variables and 250 data points. And we got a title is a string, and we got numbers for the other 2. Congratulations! You have just scraped data. It's pretty cool. This is probably the most data science-y thing we've done so far. And here's the full data, because I scraped it through this process. And we can go, we can sort, oops. So yeah, it's sorted by year. And you'll notice that there are a couple of new movies here, because every time I compile the slides, they get updated. So we know that Hamilton is now ranked 59. Soul is in the 220. Joker, Avengers, 1917. There are a lot of cool new, or there's some. Okay, there's not a ton, but this data is being constantly updated, and so it's really good to have reproducible code so you can scrape the data whenever you need it. So feel free to poke around in these slides. The table should work really nicely. Yeah. Oh yeah, before I forget, sometimes our data are messy. So, so it may or may not be, I promise this is the end. So there may or may not be a lot of work. Now I did deliberately select variables to teach you how to like deliberately scaffold up. So here with IMDB, we have pretty nice data. We can add in an extra row because it's already sorted by rank. So we can just throw in mutate and create a new variable that is 1 through the length of rows. And what that does is it creates a vector of 1 through the total number of rows, which happens to be 250. And then it moves the rank to the beginning. That's what relocate does. Ta-da! So what's next? Next kind of things that we can figure out is, well, which years have the most hit movies? 1995 has the most, but 2019 comes up right behind it, which is kind of cool. 57, 90, and so we can poke around in the data and learn a lot of things. What about which 1995 movies made the list? So we got 7, The Usual Suspects, Braveheart, Toy Story, Heat, Casino, Before Sunrise, La Haine. And I just had it print 8 here. Actually, there are only 8, so that's fine. Now, what if we wanted to visualize the average yearly ratings of movies that have made it into the top IMDb list over time? Here, I've produced a plot. It's not stellar. It gets the job done. And we can see here, we group by here with a summary, and we just take the mean rating with a ggplot. Plotting is a function of average score in year. Ta-da! And we can use geom point and geom smooth and toss in some labels. It's a really nice tight code. Yep. So I'm illustrating here that you can pipe into ggplot. I don't tend to recommend it in practice, but I at least wanted to show you what was that thing. So yeah, cool. Now there are some potential challenges here. So we might have inconsistent formatting across the source. The data may be broken across many pages, and so we would have to scrape across, and just tons of others. The data could change, the scraping algorithm or the API could be updated, it may start charging fees. There are a lot of things. So in this, I recommend saving your document down. Like, make sure you write your data file that you've scraped to your computer because it can change. It is dynamic. And so if you want, you are welcome to poke around, for example, on a Gumtree, which I just threw in Gumtree London because it's a really icky, messy data structure. And just think about what challenges you might see in scraping, like even the list of available cars. Think about it. The more you know. Okay. Oh, we're almost done. Your turn. So I want you to go through and do the same thing with TV shows. So create a data frame called TV shows with 4 variables: rank, name, score, and year. These should be pretty familiar to you. And then examine each of the first 3. So you can also grab like genre, runtime, episodes, first 5 plot keywords, and then add all this to the TV show data frame that you created earlier, apparently. Hopefully. So yeah, I'll see you all later. Bye!